One. Welcome back. I'm Steve Miller from Williams College. This is the afternoon session of Teachers as Scholars, and we're going to continue our tour of games, and we are going to play the rectangle game. So this is a little bit different than the I Love Rectangles, which we played earlier. So in this game, we have an M by N board. So think of it as a giant Hershey bar. And unfortunately, due to school policies, I can't bring in Hershey bars when I come to the classrooms, but I can at least with my own kids. And so on each turn, you can break any piece along one horizontal or along one vertical, and the last one to break wins. So does someone have a winning strategy? And if so, who is it? And is it a function of the size of the board? So in terms of a legal move is I can cut all the way down over here. That would be a legal move. But I can't cut and stop part of the way down. So let's play a little bit of a game. So the first person will go all the way down like this. And you go from boundary to boundary. The second person started the boundary here and stopped as soon as they hit a boundary. And so a boundary is going to be the original perimeter of our rectangle and then any lines we draw. If you actually had a chocolate bar, you would have actually broken the chocolate bar over here and you would have had two pieces. And then it would be clear that it stops over there. So does everybody understand the rules of the game? A possible next move would be maybe the first person cuts all the way down to here. They can't keep cutting. They've hit a line, so they stop. The next person, blue, could go from here to here, from here to here. Blue could go from here all the way to the top, but they can't go from the bottom all the way to the top. And so we'll assume they just do from here to the top. And then maybe red goes here. And then maybe blue goes there, and so on and so on. And so we can just keep playing the game. And then the question, as I said, is, does somebody have a winning strategy? Who is it? And how does it depend on the board size? So I have lots of kids do this, typically, I often do this in the third grade classroom. The biggest problem is the kids do not remember that they have to stop at a break and that they'll keep going. So you have to watch them in the beginning, but after a while, they quickly get to the point where they realize what's going on. So this is a great way to start talking a little bit about statistics, about data, about trying to gather data to make a good conjecture. And so what we're going to do here is we're going to just gather some data. So I would have the students play a huge number of times, and then I would have them record their results, and then we share as a class. So in the interest of time, I will just assume, since we don't have any little kids with us, that we have done them, and I will give you the results. So we played 10,000 games of each board dimension shown here. And amazingly, the winner was always as marked in the final column, no matter what strategy was used. On the 2x2, player 1 always won. On the 2x3, player 1 always won. Player 1 also always won on the 2x4, the 3x4, and the 4x4, but player 2 triumphed every single game on the 3x3 and the 3x5. So do you see a pattern as to when player 1 wins or player 2 wins?
Well, player 2 is winning when the sides are odd.
Excellent. Or another way of saying it is when the area is odd.
Yeah.
So
dimensions are odd.
Dimensions are odd. So that is the exact inspiration, insight that I want the students to get, and frequently somebody in the class will get that. Well, in fact, several people will get that. And now we have a conjecture. And so we're going to try to prove it. And fortunately, the first thing we did was on monovariants, so we already know something about them. So a monovariant is a quantity that moves in only one direction. It's either non-decreasing or non-increasing. So we're going to associate a monovariant to the rectangle game. And what we're going to do is we're going to associate the number of pieces. So before the game begins, at move 0, is one piece. Now we have move one, and move one goes, say, down like this and splits it into two pieces. So after move one, we have two pieces. Move two was over here, and now we have three pieces. Notice that the number of pieces is always one more than the number of moves. So we move over here, we have 4 pieces after 3 moves, 5 pieces after 4 moves, and in a really bad typo, that should be 6 pieces after 5 moves. And now the game is over. There's no more moves possible. Player 1 wins. So what we see is the monovariant is the number of pieces. Every move increases the number of pieces by 1. So if the board is m by n, we have m times n pieces when we're done. So it takes mn minus 1 moves. So if mn is even, then player 1 wins, else player 2 wins. So for instance, if the board is 3 by 5, then we need 14 moves. Player 1, player 2, player 1, player 2. Because 14 is even, we end with player 1. If the board was 2 by 3, we would need 6 minus 1 or 5 moves, and it would be player 1, player 2, player 1, player 2, player 1. We end up on player 1. So again, this comes down to if you can find the right perspective, the game isn't that bad. Okay. Any questions on this game? All right, so I'm going to stop this, and then I will reinstitute the call in a moment.